This is the Chapter 2 review, at least the last half of the chapter. We're going to graph each function. We're going to list all the intercepts, asymptotes, and holes, and fill in the blank with NA if not applicable. Blank answers will be counted as incorrect answers, and this is in reference to the DCA. So these are the instructions that you're going to see on the DCA. So make sure if something doesn't have an answer that you put NA in that blank. Let's factor first. We have x plus 2 times x minus 1 over x minus 3 and x plus 1. Let's double check to make sure we have that factored correctly. Plus 2 and negative 1, that'd be plus 1. Negative 3 and 1, that'd be a negative 2. Looks good. X-intercepts, that's what makes the top 0. So negative 2, 0 and 1, 0. Negative 2, 0 and 1, 0. The y-intercept, that's what we get when we plug 0 in for all of these x's, and we get negative 2 over negative 3, so 2/3. 0, 2/3. 0, 2/3. About right there, let's say. And I wonder if I can erase this. And yeah, I kind of need it, kind of, sort of. Vertical asymptotes. That is what makes the denominator 0. So x equals negative 3 and x is equal to negative 1. No, positive 3. Positive 3. That's what makes that 0. So positive 3. And I'm doing this on I don't even know what to call it, a computer pad. So it's not the greatest thing for graphing, but it gets the job done. There we go. Something like that. Now, horizontal asymptotes. Y is equal to 1 because we have the comparison of the powers, 1 over 1. So now the horizontal asymptotes, they're for ending behavior. So now we know how the graph ends. But in the middle, it's going to do something like this. This is not great for graphing. And then over on the left-hand, over on the left-hand side, looks something like that. Now I have no information over here on the right-hand side. Slant asymptotes, not applicable. Holes, not applicable. Is there anything down below here? There's nothing else. So we need one extra point. 1, 2, 3, 4. How about 4? 4 comma something. So we have 6 times 3 over 1 times 5. 18 fifths. What is that? 3 and 3/5. So 3 and 3/5. So 1, 2, 3 and 3/5. How about right there? And we go something like that. Next one. Hello, fluid. Can I pause this? I think I can. All right, I think we're back. We're back from pausing, so I can close some of that stuff. X minus 3 and x minus 1 is how we factor the top over x minus 2. Nothing cancels out, so there are no holes, not applicable. X-intercepts at 3, 0 and 1, 0. 3, 0 and 3, 0 and 1, 0. All right, there we go. There they are. Y-intercepts. That's what we get when we plug 0 in for all the x's. So negative 3/2. 0, negative 3/2. Negative 1.5, in other words. There we go. Vertical asymptotes. X is equal to 2. So right here. Yeah, there we go. Something like that. Horizontal asymptotes. Not applicable because there is a slant asymptote because the top power is bigger than the bottom power. So x squared minus 4x plus 3 divided by x minus 2. So x squared minus 2x, subtract negative 2x plus 3, and so that's minus 2. So y equals x minus 2. right here. So there's the y-intercept, and it's going to slant like this with a slope of 1. So there's the slant asymptote, or the linear asymptote. Linear, so crosses this point, and goes up like that. And here, it's going to cross that point and do something like this. Like that. There we go. Excuse me. Let's multiply by the common denominator. We have x. Ooh, what? Oh. You know what? It really doesn't like, my computer doesn't like this background. So I'm going to copy this. I'm going to make a new page, paste, and then it should write much better. Let's erase that. Multiply by x and x plus 2 to everybody. So this is 2x plus 3 times x plus 2. And that's going to be equal to negative x squared. X times x is x squared. So 2x plus 3x plus 6 is equal to negative x squared. X squared plus 5x plus 6 is equal to 0. And we have x plus 2 and x plus 3. And that's equal to 0. So x is equal to negative 3. We can't have negative 2 because negative 2 makes the denominator 0. Oh, what do we have here? Let's factor this. D plus 4 and d minus 1. So here we have a 1 minus d, so we can make that plus and we can make that d minus 1. Now we only have 2 unique factors. And we're going to multiply by the common denominator. So the d plus 4's cancel, leaving d minus 1. Equals 2 plus, we have d minus 1's cancel, so d plus 4. And it looks like we're going to have no solution. Negative 1 is equal to 6, so no solution. Yeah, that'll work. Solve for all of these. All right, so let's make a number line, and let's make a very rough sketch of this. We have x equals 0, negative 2. Oh, it doesn't like those lines again. Let's go all. I'm going to select all and copy. Make a new page and paste without that background, and it will do much better. All right, what? Yep. Negative 2, 3, negative 4. So negative 4 would be over here. Now, to start out, it's just less than, so that's going to be an open dot. We have negative 2, 0, and 3. There we go. So negative 4 is a cut through, but this is a 3, 4, 5, 6, 7, 8, 9. So this is a x to the 9th, so it's going to act like an x to the 3rd. So here's the ending behavior. Negative 4 is a cut through. Negative 2 is a bounce. 0 is a cut through. And 3 is a cut through. So now for less than 0, negative infinity to negative 4, union with 0 to 3. Greater than 0, it's going to be negative 4 to negative 2, negative 2 to 0. How about greater than or equal to 0? Greater than or equal to 0, just negative 4 to 0. So negative 4 to 0. And less than or equal to 0. That's negative infinity to negative 4. And then union with 0 to 3. Well, we don't compare anything to these guys here, so what if we, I guess it wouldn't really matter. Let's subtract this over. So 1 over x minus 1 over x plus 5 is greater than 0. Let's get common denominator. We'll multiply this by x plus 5 on top and bottom, this by x on top and bottom. So x plus 5 minus x over x times x plus 5, and we want that to be greater than 0. Well, that becomes 5 over x times x plus 5, greater than 0. And the points that we're interested in is x cannot really be 0. X cannot be negative 5, but this can change signs over those values. So we have negative 5 and 0. And we cannot equal those. So negative 6. Negative 6 times negative 1 is a positive. How about negative 1? Negative 1 times a positive 4 is a negative. And if we plug 1 in, we get a positive times a positive, that's a positive. Now we want greater than 0. So negative infinity to negative 5, union with 0 to infinity. Over here, again, we don't compare anything to 3. We compare stuff to 0. So we have x squared minus x minus 11 over x minus 2. Minus 3 is less than or equal to 0. Now we got to get the common denominator, so we're going to multiply the top and bottom by x minus 2. X squared minus x minus 11 minus 3x plus 6. We get x squared minus 4x minus 5, and that's over the common denominator of x minus 2, less than or equal to 3. The top factors into x minus 5, x plus 1, over x minus 2. Oh, not less than or equal to 3. Excuse me, less than or equal to 0 because we subtracted that over. That's less than or equal to 0. So now we're interested in x is equal to 5, x is equal to negative 1, and x cannot equal 2. You can never allow the denominator to be 0. We have negative 1, and we can equal that. 2, and we cannot equal that. And then 5, and that's okay. So negative 2 is negative 7. Let's see, negative times a negative over a negative. So positive over negative, that's negative. 0 is a great one to try. 0, we have negative, positive over a negative. So negative over negative, that's positive. And with, what is that number? That's 2. 3, negative, positive, positive. Negative, positive, negative over positive is a negative. And if we try, let's say 6, positive, 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 positive. Now we want all the negatives. So we're negative infinity to negative 1, and we can include negative 1. What do we want? We want negatives 2 to 5. Union with cannot equal 2, but we're okay with 5.